on to the last two major rules in this section, product rule and quotient rule. When we started our basic rules, I gave you this warning right here, that while it was permissible to break up derivatives by addition or subtraction, it was not true for multiplication and division, products and quotients. And what we've always done so far is we got rid of products and quotients by multiplying out, using negative exponents, that sort of thing. It won't always be possible. So when it's not possible, you're going to use either the product rule or quotient rule, depending on the problem. Let's talk about the product rule first. Product rule says the derivative of f times g of x is f of x times g prime of x plus g of x times f prime of x. To help us memorize it, if whatever is written down is first, I call first, and whatever is written down second, I call second. We can memorize this as plain first times the derivative of the second plus plain second times the derivative of the first, or even shorter, plain first, derivative of the second plus plain second, derivative of the first. You've got to memorize the product rule. So let's now practice the product rule. Differentiate the following. And we're going to use the product rule because that's what we're trying to teach here. But even though I'm going to use the product rule, I still do basic stuff, which is rewrite that radical with an exponent and that fraction on the end, rewrite it with an exponent. And so this first factor here, I'm going to call first, and this second factor here, I'm going to call second. And now I'm going to apply the product rule. First thing I'm going to do is just write out what the product rule says to do. So it says plain first. So just write down that first factor, but don't do anything to it. Derivative of the second, and I'm just going to do it in symbols for now. So there's derivative of the second in symbols, plus plain second, derivative of the first, again in symbols. So we've got plain first, derivative second. DERIF always stands for derivative. Plain second, derivative first. And I haven't actually taken any derivatives yet, just writing down in symbols what it says to do. Now you do not have to show this step. I will continue to show this step until I'm relatively certain people know what the product rule says. I'm not expecting anyone to show this step, but if it helps you get the answers right, you certainly should show this step. Now actually taking my derivatives, plain first. So don't change a thing. Be careful that you don't make any sign errors or something silly like that. Then a derivative. Derivative of x, 1. Next one, multiply by the exponent, so that goes to positive. Decrease the exponent by 1, so negative 2. I'm up to the plus sign. Plain second, so don't do anything, just copy it down. Derivative of the first. Derivative of x squared, 2x. Derivative of 2x, 2, and on the end, multiply by the exponent, decrease the exponent by 1. And that is my unsimplified derivative. That's not how you spell simplified. We are actually going to simplify it. When simplification is a matter of just multiplying out and combining like terms, we are going to simplify. Simplify by first multiplying out. And let's recall that when I'm multiplying with exponents in the same base, I add my exponents. So a nice little example here that's going to creep up. X to the 1/2 times x to the negative 2 is x to the 1/2 plus negative 2 for x to the negative 3/2. Okay, so let's very carefully start multiplying this out, being really careful that you don't screw up any signs or anything like that. So multiplying this first guy here, x squared times 1, x squared. 2x times 1, 2x. X to the 1/2 times 1 minus x to the 1/2. Be careful with that minus sign there. And then same thing on the next one. X squared times x to the negative 2 will be 1. Add the exponents. Negative 2 plus 2, or 2 plus negative 2 is 0. X to the 0, x to the 0 is 1. 2x times x to the negative 2. Again, add the exponents. And so I'm going to get 2x to the first. 1 plus negative 2 is 1. And then on the end, minus x to the negative 3/2. 1/2 plus negative 2, negative 3/2. Then make sure you didn't make any stupid little sign errors. And so I would have 1, 2. That I think is right. I'm going to drop down because I'm running out of room. Then doing the same thing on the next one. X times 2, 2x squared. X times 2x, 2x squared. X times 2, 2x. And x times negative, so negative 1/2. Then add the exponents, x times x to the negative 1/2. X to the 1/2. Keep going. Be careful with the signs. That's going to be minus 2. X to the negative 1 times x, those x's essentially cancel. Then minus 2x to the negative 1. And then plus, add the exponents. And don't forget about that 1/2 in front there. So plus 1/2 x to the negative 3/2. So 2x squared, 2x minus x to the 1/2, negative 2, negative, I think that's right. Then combine like terms. And so all we did on that previous step was very carefully multiply it out. Now combine like terms. X squared plus 2x squared for 3x squared. 2x plus 2x for 4x. X to the 1/2 minus x minus 1 or minus 1/2 x minus x to the 1/2 minus 1/2 x to the 1/2 would be minus 3/2 x to the 1/2 plus 1 minus 2 for minus 1. I think there's an error right there. Yeah, this is supposed to be 2x to the negative 1. Forgot to write down an exponent. Yeah, that should be 2x to the negative 1 right there. Forgot an exponent. And once I correct that, plus 2x to the negative 1 minus 2x to the negative 1, those cancel. And then finally, negative x to the 3/2 plus 1/2 x to the 3/2. Add those things together. And I got a sign error right there. I just wasn't careful enough. Or maybe I don't. Well, let's see. That's going to be minus 1/2 x to the negative 3/2. And that should be my unsimplified derivative. And I do think that's right. So there's my unsimplified derivative. Okay, we got it done, but it wasn't a whole lot of fun, and I'm still not completely confident that it's right, but we're going to check our work now, and hopefully this comes out right. But there we did it with the product rule. Now we are going to do this again, but we're going to multiply out first. And hopefully we get the same answer. So the original problem way back when was x squared plus 2x minus the square root of x times x minus 1 over x. And we are still going to rewrite that as x squared plus 2x plus x to the 1/2 times x to the negative 1. And then we are going to carefully multiply that out first. So, x squared times x cubed, 2x times x, 2x squared. Almost made an error. I'm just having huge issues with these signs. That's supposed to be minus right there. And that's one thing you want to be really careful when you do your work. Be careful of those signs. X the negative 1/2, or negative x the 1/2 times x is going to be minus x to the 3/2. Add those exponents. And then doing the same thing on the end. X squared times negative x to the negative 1 is going to be negative, then add the exponents, so negative x. 2x times negative x to the negative 1 is this going to be negative 2. And then negative times a negative is going to make that positive. Add the exponents, x to the negative 1/2. And that is still my original. But it's in a more calculus-friendly format, and let me check it real quick. X cubed, 2x squared, x to the 3/2 negative, negative x, negative 2. Okay, I believe that's right. But now I can just use my basic rules. I can just do my power rules here. And so multiply by the exponent, decrease the exponent by 1, 3x squared. Multiply by the exponent, decrease the exponent by 1, 4x. Multiply by the exponent, decrease the exponent by 1. Derivative of negative x, negative 1. The derivative of the 2 is 0, so I won't write that down. And on the end, multiply by that exponent, decrease the exponent by 1, and there would be my simplified derivative. And let's compare. First answer and second answer, 3x squared, 4x, minus 3/2 x to the 1/2, minus 1, minus 1/2 x to the negative 3/2. They're the same answer, so I feel really good that they are both right. But the second way was much easier. So the moral of this story is whenever you can multiply out first, multiply out. Simplifying first is always easier when it's a possibility. And we'll conclude that video.